was one update. I always thought March was our snowiest month, and it generally I think is on average. But one of our snowiest months ever was in April in Duluth. So we had like 50 inches of snow in an April.
So it's not that.
Yes, let's hope it's not that. Got a lot of snow in this month. Okay. All right, so we're gonna start unit 11 today. Their due date, the unit. Okay. I'm gonna start unit 11 here. We're gonna talk, so we've been talking about virtual machines 2 weeks ago, and those are big virtual machines we can run in the cloud or we can run on our computers. They have a full operating system. They're gigabytes of space. They're big things, chunky things. And it's just like taking a whole computer server and running a virtualized version of it. They're very helpful when you want to do something like that, to simulate a whole virtual machine there. But again, they're big. Then last week we talked about containers. So containers, you're running on an operating system and you're sharing an operating system and you're just basically setting up the environment, all the libraries, all the stuff to run on your system in a container, and you're running an application inside a container. I don't have the screens on, do I? I don't have the screens on, do I? It says it's on. Oh, one's coming on. Okay. There. Okay, good. So again, we looked at containers. We're running these apps inside a container on a server. But again, it's using the host operating system here. Now we're going to do even less, a smaller framework and something called a Lambda function, and run things on a Lambda function. Lambda functions can mean two things in programming or in computing. In programming, like when you're in Java or something, you can define an anonymous function that doesn't have a name. And when you're running like your Java program, you can just say, when you need a function, just create a function without a name and call it a Lambda function. It's called a Lambda function then. So that's one term for Lambda function. This is different, but kind of you can see why they share the same name. This is when we're running a function without a server. So rather than a function without a name like you do see in coding, this is a function without a server, without a place to run it. Again, it has to run somewhere, but it's kind of runs virtually in the cloud there. So you don't have to have a dedicated server. You don't even have to have a container. You can just run some code out there. And so that's what these Lambda functions are. And we'll also talk about what are called microservice architectures, which make some use of Lambda functions, but also some use of containers, which is a common architecture today here. So let's go into the readings. You might also want to open up the exercises and we'll look at those some. So again, we're talking about virtual machines. Versus containers versus Lambda functions here, and what the difference is for those here. And then in a little bit, we'll try some of these tutorials out. But first, we're going to just talk about this. I'm going to go into the readings and videos here. So again, this is new stuff. It's not in our textbook. So we're going to look at a couple things. The first thing we're just going to go over a little bit is Microsoft's Quick Start for .NET developers. And this kind of talks about these different architectures that are out there for this. and shows some of these different architectures that are here. So again, they're trying to sell their cloud services for these, but they're talking about how this stuff is set up. And so they're going to talk about virtual machines and how you can set up virtual machines and some of the advantages about them. But then they're going to talk about microservices and containers and this microservice architecture for that. And that's going to be much more common that we're going to see is this microservice architecture here. I'm actually going to jump to this. So again, they all talk about creating services, installing Docker and doing that. So this is much more related to our last week's stuff where we're creating Docker stuff here. So again, a lot of systems now are running and creating this microservice architecture. So when we teach like our software design class, we teach this microservice architecture. It used to be, let's say you want to make a website, you would create a web page and a database system, a bunch of web pages, a bunch of code, and maybe you're writing it all in JavaScript here, and then or some backend framework or some combination of a front end backend framework. But again, a lot of that is served from a big web server, so you need a web server and for that website. And so it's often would be a virtual web server and it will be running some web server software. And the whole website and the database for it would all be together on one big server package, one big virtual server. So that's the old school kind of way of running a website. The new way with containers is that you break that into multiple little parts that talk to each other. So maybe you have a database that tracks your users and you have a login so users can log in. So you have one service that just manages your user connections and user logins there. And maybe your users, maybe you're doing e-commerce, or maybe you're selling products. So maybe you have a catalog of products you're going to sell. That catalog with the pictures and the database of what you sell would be in another container there. And then maybe users will put together an order and order something. So that order would be in another container to manage an order, and it would talk to the other containers to get the products information and get the user information, because all that would be in for one order for that. So you'd have multiple different containers, each for different tasks, each with their own little database running, and they could be running on the same server or they could be running on different servers because they're each in their own container. So that's kind of last week's version of things. Now you can actually set up websites that don't even run on containers, that run on kind of a serverless architecture, and we just spin up and run functionality that talks to backend cloud services by itself. I'm currently working on a project, and we use for a website, we use something called Amazon Amplify, and we write JavaScript code, but we are not running on a server. It all is run on Lambda on these serverless architecture, and all connects up to Amazon stuff. So if we need a database, there's a database there in Amazon that we connect to and grab. If we need user authentication, there's a user authentication thing in Amazon that we connect to and do. And so we don't need a whole server, and we don't even need containers with their own database. All that stuff's in the cloud, and so we can run these Lambda functions. So that's where we're seeing the smallest kind of component of this stuff. So I'd ask you to do this. Go to Unit 11, go down to the readings and stuff, and click on this, Learn with AI on Lambda functions. And this is what I do in another class where we're covering material that is too recent to have a good textbook on here. And we're going to do the same thing today. What I'm going to ask you to do is just for your own notes is basically create your own textbook chapter on this. So we're going to, I suggest you make a copy of this. So you can go and make a copy of it. And then we're going to ask AI to fill in. So I've created an outline here of what I want to talk about with some bullet points. And we're going to ask AI to fill in those bullet points. So I'm going to fill in these bullet points here. So I'm going to run ChatGPT here. And I'm going to take this code. I'm going to take this beginning statement here. Explain the following topics to me as I'm learning about serverless or Lambda functions. I'm going to paste that in, and then I'm going to paste in this introduction stuff and say, this is my topic. And we're going to have AI write our little textbook here. Zoom up a little bit here. So, oops. Yeah. Okay. So again, this provides an introduction to what are Lambda functions. What does it mean to be serverless? How do Lambda functions work? Why do this? And a summary of this. I'm just going to grab that. I'm going to skip over the summary, I think, and just grab the rest of this. I'm going to put that in. And right after this, I'm going to paste that in here. Here. I know we're going to talk about. While we talk about it, I'm actually going to take this next thing and talk to my AI. I find it's nice to be nice to your AI, so I'm going to say, thanks, that was good. Now tell me about, and I'm going to paste in the next topic there. Okay. Now I'm going to go in and kind of edit this. I pasted this in, edit this textbook, this introduction. So what does serverless mean? Again, it means no server. We don't have to have a dedicated, so it shouldn't actually be called serverless. It should be no dedicated server here. So we can run our app, we can run our functions without having a dedicated server for that. So you basically write and upload a function. So some code, it can be a Java function, a Python function, a JavaScript. It tends to be more JavaScript or Python than bigger languages like Java or C#. So we often do this in some of the smaller scripting languages like JavaScript or Python here. And in our cloud platform, we'll automatically handle the whole infrastructure. It'll have a server to run this on, and the function will only run when triggered by a request, by an email, by something here. One place where I've used these, in my mind, it makes the most sense, is that I have a little Alexa at home. Actually, I have like 5 Alexas at home. These little smart devices. And so I can tell Alexa, turn on the living room lights. We also have Alexa in our cabin. And so sometimes we accidentally turn the lights on in our cabin too. That's all. So we have Alexa, and there's some built-in stuff to do lights, but we can program our own little devices. I can create a little Python function that does something out there, and then I can tell my smart device, I can tell it to do that function, and that it will go out and trigger that function there. So when they talk about when it's triggered by something, It could be something like your smart device or your phone telling or running some thing in the cloud or something like that. It also could be your website clicking on something, doing something or something. So there's some sort of trigger that you've set up that configured with the cloud to do that. And we're not going to get too much into how those triggers work in this class, but just so you know, there is that. So again, we might like say resize an image. A typical example is like every time I store an image in this Google Drive folder or this Amazon folder, every time I move an image to that folder, it will look at that image and resize it and shrink it down to this size or standardize that size. So that's a common example of that stuff. We write the function to do what we want. We deploy it to the cloud. We set it up somewhere in one of these services, and then you define your trigger when it's going to be done. When a file is uploaded or an API is called, or you tell Alexa to do something here. So why do we use these things? They're very cost effective there. So even like with a server, you will pay when that server is up. So if you're trying to run a website, you have a virtual machine, you are paying $0.25 every hour to run that machine. Well, not a quarter, maybe 5 cents every hour to run that machine there on that virtual machine. Well, it's only 5 cents, but you're running it 24 hours a day, 7 days a week, 365 days. That adds up there. So you've got it, you're wasting a lot of resources there. So again, you can get a lot less expensive server, but you're still spending resources on that there. Even containers have to be on a ready to go on a machine, on a server ready to go. These are so small that they can sit there and not be running. And then when you want to, you can just run them there. So scale there. They're very cost effective. They're very scalable. So if one person does this, or 1,000 people or 1,000,000 people do this, the cloud facility can just run this on multiple servers all over the world and manage this load for this. So, and you don't have to worry about server management. You don't have to worry about updating your server or your container or anything like that. So, okay, now let's go over and compare this to virtual machines and containers. So again, I asked AI. ChatGPT is really into emojis. I would just ask if we could all just agree whenever ChatGPT displays this version or this version, we always choose the version without emojis in it. That's my preference. I'm old. I would just like that. We could all do that. So, okay. Here's our thing. And I'm going to go and talk about the key characteristics here. Tell me about okay. We talked about VMs, and again, I can almost go back to this picture here. Each VM has its own operating system and libraries and apps, and we run that on another operating system. So that's what basically it's saying here. Each VM contains a full operating system, binaries, libraries, and the application. It's heavyweight, consumes lots of memory and disk, boots slow here. But it offers very strong isolation. It runs by itself and is not connected to anything else here. So if we look at containers here, they share the same operating system. So again, they have the same operating system kernel, the same operating system. They're faster to start than VMs, seconds instead of minutes. They're resource efficient. No full OS, and they're highly portable. We can move them from one place to the other very easily. So now serverless Lambda functions are, again, the smallest, lightest weight version of these here. So again, this is this where we just are, they're in the cloud somewhere. All they are is this app that runs, basically. No container engine or whatever. They run very fast, scale. They only take like 100 milliseconds to run and use that much. So they spin up really fast, run really fast, and stuff there. Now they're generally stateless and short-lived tasks. So if you have to maintain state, remember things from one call to another, that can be an issue. And that is actually, again, I mentioned this, websites generally maintain states in your web page there. So, but some of that can be handled by keeping the state in the browser rather than in the server side, stuff like that. Okay, what are the key characteristics of a Lambda function? And again, that should be a lot of repeats. Let's see if that's a repeat of all this sort of stuff. Oh. So again, they're stateless. We just talked about that. They don't remember anything between execution. So you can't run them and have them check. So for example, you can't have it remember if your lights are on or off. And you couldn't say, switch your light. I mean, it won't remember that you turned your lights off and then you should turn them on. Now, you could just say, turn my lights on, it will do that, or turn my lights off. But it doesn't remember. It can't remember what it did last time you did that, something like that. So that sort of state information there. And again, websites can get hard too. And so there are ways around websites actually, but sometimes that stateless is just fine here. Event driven. So again, the HTTP request, a web request, a file upload, database change, a schedule event. What we see these a lot is that like we can run apps that'll use a cloud-based database, like something called, like when we do it, mobile apps, we run something called Firebase. You can set up Firebase is a Google cloud environment where you can set up Firebase. So anytime you write to that, you update some data, some Lambda function will run to do something with that data. So maybe every time I just update an order or write an order to the database, my Lambda function will then print out the mailing label or process or schedule that order for shipment or something like that. We'll process the next step of that order there. So anytime we update a database, we can trigger a Lambda function here. Again, a lot of cold starts here. So if a Lambda function hasn't been run for a while, it can be kind of slow. And every once in a while, you'll see this with certain web pages or something like that, where the first time you access it will be a little slow. I mean, especially if you haven't accessed a website in weeks there, the first time it's accessed, it'll be kind of slow. And then the next time it'll be faster because again, sometimes it takes a little bit for the cloud infrastructure to start this up. And what this often is referred to as a cold start versus a warm start for this stuff. Okay. We do have resource limits. Like one thing I run into a lot with Lambda functions is that I often will want to run a Python script and will want to bring in some Python libraries. And again, those take a while to load in sometimes. And every time you run the script, you have to load in these Python libraries. That's really not going to work for that. So you can look at can you store some memory, some stuff with that. So again, with some Lambda functions or systems, you can preload the libraries. That's why in this picture, they're showing the app, but also maybe some preloaded libraries that will be all ready to go for you. But again, there's a limit depending on where you're doing this. let's just do a quick look at the comparison of these things. First, we'll look at AWS. So Amazon's AWS is the best known Lambda functions, and they're called Lambda because AWS calls them Lambda functions here. So this is the main situation. So again, this is its serverless architecture. Lambda, AWS Lambda is what basically defined this. They're integrated with the rest of the Amazon situation. So like storage, you're talking about like if you take a picture on your phone, often those apps will store that in an S3 storage system, store the image there. And then you can, when that happens, you can trigger a Lambda function there. Same with this DynamoDB. If you say something to this DynamoDB, that can trigger your function to do something here. Same with different logs and stuff like that. They have limits on how much memory and stuff they can do. Their pricing there. So here's an example. The first 1 million accesses per month is free to run this. So again, for most of the stuff we do, it's going to be free because most of the stuff I don't do 1 million times a month there. But yeah, if you're a startup and you have 100 million customers, that's going to be a different ballpark. But that's where we're at. Deployed, the traditional way of deploying this is to take your function and the libraries like the Python or JavaScript function libraries and put it into a zip file and upload it to Amazon. Amazon will unzip it and set it all up with you. You can also do this as part of a container image there if you need more dependencies. And they'll kind of run this as a hybrid between a container and a Lambda image. As long as the Docker image, as long as your container is not big and doesn't have too many libraries in it, you can do it that way. But again, the zip method is much more common for Lambda functions. When I copied this, I'm going to try to do this copy over again. And I did copy before it was all over. Okay, let's look at Azure. Let's see if it's smart enough just to tell me if I ask about Azure, if I just paste that in there at this point. Okay. So again, Azure is Microsoft's functionality here. And so we're going to look at how that compares to this. So similar stuff, we're stateless by default, we're event-driven, we scale automatically, we integrate with the Azure operate or function. So again, Azure blob storage, that's similar to like S3, where again, we can store images to be resized or moved or reviewed there with the blob functionality. Events, the Cosmos DB is very similar to the DynamoDB. Again, when you're storing things out there, we can do it. And then again, HTTP triggers, timers, that sort of stuff is all there. Say scaling is and again, what you see here is that these are all competitors with each other. So again, Azure has to give the first 1 million executions per month free also. And after that, it's about 20 cents per million executions there. So again, very reasonable priced to run this sort of stuff here. let's look at Google. And again, what I mainly want to see is that these three will be very similar to each other for this. Sorry, I said Google and my phone gets excited because it thinks it should be doing something here. So again, integrations to this Google Cloud Storage, Google Firestore. I mentioned Firebase. Firestore is the new version or replacement kind of version of that. So it actually integrates with both Firestore and Firebase databases, HTTP, Cloud Scheduler, our timer. Oh yeah, and then Firebase. So it integrates with all of these things. First 2 million things a month are free, so they're going to try to compete on that. But similar sort of functionality here that we see. So I could say if 10 events or 10,000 events come in, Google Cloud will spin up as many instances of servers as needed for this sort of stuff. So finally, let's just ask for use cases for this where we've already talked about some. Let's see if it comes up with any more creative examples of where we could use these. I bet it's going to mention the image resizing stuff. I wonder if it'll mention Alexa or something like that. So yeah, I've used this. I'm in fact using this right now on a chatbot integration where again, where we have a website, we type in a chat. Whenever we type in some chat, we spin up a function that calls a large language model with that chat information and gets the information back from the large language model, displays it on a web page. So that sort of chatbot integration here is pretty common. So data transformation, cleaning and validating data. There are a lot of times where you'll do this where, again, you might every month some spreadsheet or some information might be brought in or stored somewhere in your cloud, and you'll just have to do some basic processing on or cleaning up of that spreadsheet here. File processing, I mean, like when you upload something to YouTube, it automatically will process it and manage it, and a lot of that back-end stuff is moving it around to different buckets that generate kick off Lambda functions to do the different file processing to those videos as needed. Let's look at when not to use Lambda functions. Again, they're kind of showing us, again, Lambda functions, containers, and virtual machines. So these short event-driven tasks, microservice endpoints, that sort of stuff are good for Lambda things. Longer running processes, things where you'll be working and managing something that needs some state, those aren't great fits for Lambda functions. If there's some custom runtime dependencies or libraries you may have to bring in, sometimes that can be tricky with these Lambda functions here. Any sort of stateful legacy applications, again, that have to run and are coordinated with a particular operating system, a particular version, those often have to run on a virtual machine. So I've seen people who are, again, running a certain system that manages, like, I know like our chemistry department has some certain machines that run some chemical analysis, let's call them, and they have a PC that controls that machine. That PC has to run, you know, and it hasn't been updated. It's fixed to this one machine. It's running Windows, you know, XP or some old version of Windows or whatever. And so they've replaced that. They can replace that by a virtual machine, but again, it's all hardware tied, so they really have to be running an old version of Windows to connect to that specific device out there for that legacy application. So. Okay. let's jump. So that's just an overview. Let's jump back into the exercises and talk about those. So again, I'm going here and going to the exercises and bringing those up here. So I'm going to walk through this, but again, there's a little video here that will talk about creating your first Lambda.
Spend just a couple minutes talking about some theory, what it is, why you want to use it, and then we'll dive into some hands-on. Imagine you're working on a project called TinyClips, a platform that caters specifically to short films under 5 minutes. The basic flow looks like this. The user uploads a video, and then the application needs to do a few things. Create a small thumbnail for the video, a large thumbnail, and then also create an HD version of the video. And once all that's done, the video will display on a page where users can watch it. Let's talk about how AWS Lambda might work in this scenario. First, you've probably heard that AWS Lambda is serverless computing. But what exactly?
Okay, so I'm going to, I mean, this is actually a pretty good video, but you can watch that on your own here. So we're going to just talk about this. And again, all you have to do is describe what a Lambda function is here. So by now you should build that anyway. So this is some information from AWS on Lambda functions, on how to create your own Lambda function here. Again, to actually do this, we need an AWS account. You can create your free, or yeah, I don't know if you need a credit card or how you have to do. I have an AWS account and a couple of AWS accounts. I'm not quite sure how they work for everyone, but you don't have to create one. We're just going to read through the tutorial here for this. So we're going to create a Lambda function with the console here. So again, we can bring up the console, but we're just going to read through the instructions here, not do this. So again, you can do this. Often it's in JavaScript. In this case, they're using a version of JavaScript called Node.js, or you can do this in Python here. So you can be working with either of these two. And again, they'll have an editor. So again, we talked about how you can upload this as a zip file, but you can also create this right in their console in their editor. So if it's a small function or you already have the code ready, we can just put it in there. So in their stuff, you can create a Lambda function, just specify what language it is, and put in the code here, and you can just deploy it here. So here's their sample JavaScript. Let's do Python, because we've done a little bit of Python code in here. So again, here we're just calculating the area of something. So we have some event come in that has the length and the width as part of that event. We're calculating the area, and then we're logging that out there. So it just walks you through that code. And then again, we can create some test event and again, inside your code, you can create a test event that'll run this. You have to specify the information you're sending to this Lambda event. So we're sending a little packet of JSON information here, which has the length and the width in it. And again, JSON data has to be formatted a certain way where we have attributes and values separated by colons. And then multiple ones have commas in them. And then we have these braces here. We're not going to get into how JSON has to be formatted. We don't need to do that. But again, we're specifying that, and we're sending that as our test event for that. And then it's replying with some event. And again, we can do some logging and that sort of stuff. So then that's just kind of so it shows you how you can do this. And again, you can actually create this, again, in JavaScript. Now, there's a new version of JavaScript called TypeScript, which a lot of people are using, which is just requires you to better specify the type of variables, what data type all your variables are there. Python, Ruby, Java, Go, C, Sharp are all things you can do this in, at least at Amazon. Okay, so write a description of a Lambda function here for this. I'm also fine with you asking AI for a description of it, but I don't want you just to paste in an AI description. So you can certainly ask an AI for a description, but then it's really helpful if you internalize that by rewriting it, typing it, or stuff like that. So I mean, AI is a great. I run in my mind. AI is always running in my side monitor. I'm doing stuff in this monitor. And I like AI running over there so I can ask it questions. But again, it's good to internalize stuff, learn things, and bring it over here. And sometimes with code and stuff, I just copy and paste. But a lot of times I read it and then I want to make it my own there and internalize it. So feel free to do that. Okay. Now we're going to talk about microservice architecture. We're going to read a little bit about this. What is an Azure function here? So again, page 9 talks about Azure function. So we're going to go on to page 9 here. There, those are Azure functions. Azure functions, also known as serverless compute. So you can see Amazon AWS coined the term Lambda functions. And so the other competitors don't want to call them Lambda functions because they don't want to, give credit to AWS. So we're not calling them Lambda functions. We're calling them Azure functions because we're Azure, we're Microsoft's cloud environment is Azure. So we're calling these Azure functions there. I wonder what Google will call their Lambda functions. Oh, who knows? So Azure functions enable you to create Azure functions in C#. So C# is a language developed by Microsoft as a clone of Java, and Microsoft uses it and promotes it a lot. So their first thing is they're going to promote C# as their language, and many other languages. They said that's fine. They can do it in Visual Studio. Today we use VS Code a lot, which is a stripped down version of Visual Studio, but you can create these and deploy these in Visual Studio or VS Code quite well. Each function will, or each function app will contain one or more Azure functions and provide integration with authentication and deployment if needed. They run Azure functions, run a small piece of code that you write without having to worry about the underlying infrastructure. There's this whole mode of stuff, something as a service. So we first, I think SaaS was the first acronym like that, software as a service. So companies would sell software as a service to other companies. So maybe you had a payroll system. You would not develop your own payroll system. You would pay a company and use their payroll system. So company just sold you access to payroll systems, and payroll was a software as a service there. And since people made lots of money, everyone's using that still. And so because of that, as a service is a real common phrase there. So you'll talk about servers as a service, or web as a service, or AI as a service, or anything like that. So it's just anything that has that built off SaaS. So fast, I don't like that. Oh well. So again, they're simple, triggered by a wide variety of events. Here, there's an event grid we can look at that could trigger these stuff. So you can set this all up, and I thought this had a list. It just tells you how to schedule your event grid to do this sort of stuff here. So again, there's a trigger that runs these. Scaling is done for you here. They also have something called durable functions that have some state information in them. And so we haven't mentioned that, but there is something called durable functions that provide a little more information with that. Okay, so describe what Azure functions are and how are durable functions different than Azure functions. So here, we'll ask AI that. So AI, describe. I'm really not a big fan of AI being so friendly right now. It's always telling me it's great question, exclamation point. Like, well, that's a little, I wish I could change. I want a drop down where I can just change the tone a little bit. just like on my phone, I changed the voice. I would like a night. I prefer a little bit of sarcastic and a little bit of British humor, I think, with this rather than what I get. Okay, sorry. So observed functions are normal functions, durable functions, special extensions that add stateful orchestration here. So again, state workflows and orchid functions. These are good for a work. So the key differences is state management here. And again, durable functions can be running for a while. So I don't know the difference between a stateful function at Microsoft and a container. So to my mind, I wouldn't be surprised if under the hood they're basically the same names, or two different names for basically the same thing there. But again, durable functions are running as with state information and around for a longer time. So, last thing, we want you to read these articles and find a quote from each one on here. So open up this, what is microservice architecture here. Find a quote from this, paste that in here. Microsoft has their own thing about microservice architecture. Find an example of that here. And again, what this is looking at is we have multiple microservices here, and we'll have some sort of client or gateway there. Most of your web or like apps on your phones are probably running that connect to the cloud are probably running a microservice architecture. So again, the client is probably your phone client or your website. Both of these will work the same way. And they're connecting to an API, which is accessing these services and different things. Any sort of app that needs some data and pulling data. And again, that's all your social media app, all your email apps, all that sort of stuff is using this microservice architecture. And that's why often you'll have an app on your phone and a website, and they'll both be accessing the same data on the back end. Like I have an app that reads Reddit, and I have my phone and my tablet, and I have on my machine, on my PC, I go to Reddit, the website. So all those three things will be different clients, but they all connect up to the same underlying microservices that they'll use. And they might display them and slightly different functionality here at the client end, but most of the logic will be in this microservice backend here for that. So, okay, so hopefully you can go through and do that exercise. I'm going to now spend some time talking about the project. And so I'm going to close out some of this. Okay, we did that. So a couple things in the class. Don't do Unit 12, even though Unit 12 is available now. I've had a request from a couple students who want to work ahead for various reasons to have 2 units available ahead of time. And I see this pretty commonly this time of year where, some students are trying to get prepped for the final, once we hit April, things get kind of chaotic here. So they're trying to get, especially if you have, 4 final papers due or something like that in finals week, they're trying to get ahead. So to prepare for that, I will try to keep both units. So all the dates for the units will be here. So we are in Unit 11, even though Unit 12 is there and ready to go. So you feel free to do that. But again, if you look at Unit 12, all the dates are not until April 13th there. So those are those dates there. So just be aware of that. The other thing that's now available is the final project here. And let's talk a little bit about the final project here. We're going to do this in a sequence of phases for this. Oh, I didn't update this. Okay, so one of the things I want to mention is that we used to do this as with a partner because we didn't have that many Raspberry Pis during the pandemic here. So if I look at phase one here, partner solo, you are required to do this individually. So there are going to be places here where I'll say something about a partner. You can have an imaginary partner, you cannot have a real partner in this. So everyone's going to do this on their own here. So just be aware. I'm trying to clean up the guidelines. I was just looking at the guidelines, and right away it's talking about picking a partner here. So I'll clean that up. But the first thing, so what you're going to be doing is doing a project with your Raspberry Pi. It's got to be some sort of project that uses your Raspberry Pi to do something. There's a bunch of different project ideas here that are available. There's lots of YouTube channels and websites that list different things. But some common ones are like a portal or a dedicated like cloud-based hard drive that you could have at your house, what's called a network storage box here. You could do a kit and have a little car that you could drive with a Raspberry Pi. So there's two options. One is you can actually do some integration if you're a mechanic or work with a regular car to integrate with your car. There's some ways to plug in or configure Raspberry Pi to a real car. But we also have a kit that is just a little car, little model car and wheels, and with the Raspberry Pi, you can program that into now I only have one Raspberry Pi car kit, so we can't have everyone doing that, but I do have one of those available. One of the most common ones is these gaming machines, which I call a RetroPie development here. So you can program your Raspberry Pi to run old games there. There are what are called, a lot of people have taken old games, the old ones that used to come on a cartridge, like a GameCube cartridge, or was it a CD? Yeah. Or like the old like Game Boy cartridges, or the old even older, NES kind of cartridge sort of stuff. Those sorts of games. They've taken the software out of those, copied them out into something called a ROM. And then their ROMs are variable. And so then you can load those ROMs on your Raspberry Pi, run a special operating system so that when you boot your Raspberry Pi, it looks like a retro game object. And again, we have some controllers. We have some retro controllers. I probably have 10 different controllers. And again, we can connect everything from a modern, wireless controller to a wired USB controller to a retro feel controller, so you can play these games these classic games there for that. And you could probably, again, to play anything up to maybe like a PS1 kind of game there, and there are probably ROMs for those era of games also. But I in my mind, it's best. It's more even the old classic ROMs are even fun. So there are ways of doing that. So we could talk about security systems and cameras there, and doing stuff like that. A baby cam or a pet cam, so you can set up. I think I have 4 different little micro cameras that can be plugged into your Raspberry Pi, and you can there's different software and different things you can look at to set that up so we can run that I haven't looked, I don't think I have pies, but I have these little trail cams that I have out for the outdoors. They're these little cameras in a plastic case with a motion sensor on them. And I put those out so that when, the fox walks next in through our yard, takes a picture of the fox every week. I get to see when the fox is going through our yard, stuff like that. You can create something like that with a Raspberry Pi for this stuff. So again, there's different options here, and we'll talk about that. But you should start thinking and doing that. I suggest you start going to your social media and start Googling or searching, Raspberry Pi projects. So, I don't know what social media stream you're doing, but whatever it is, just do Raspberry Pi projects and maybe just start following some creators that do fun Raspberry Pi projects. Some of them we can certainly do, some of them are going to be too complicated for us to do, but at least they'll just start getting you thinking of a fun Raspberry Pi project. So everyone will do a Raspberry Pi project, and I'll be different. They won't all be different. 3 or 4 of you are probably going to do RetroPies, but other than that, they'll be. And again, I've got some cameras, I've got some joysticks, I got one car I'll bring in here, kit. I'm trying to figure out what else I had. So I have a little portable screen with a Raspberry Pi case with a portable screen, so you can do kind of like a Game Boy or some sort of a portable device there. So we'll bring that and we'll talk about that in the future. But start thinking about those sorts of things for the projects here. So again, we're going to do this in steps here. So the first step is to figure out your project ideas, and we're going to do a review matrix where we're going to say, oh, this is one idea, this is another idea. So you have to come up with 3 different ideas here, and then you're going to say which idea do you want to pick for this. So you're going to research 3 different ideas and submit a document with that, and then a stuff. And then we're going to do a paper version of this document of our project and create what is a little design document. We're then going to create what we call a minimum prototype, a minimal working version of this stuff. And then we're going to do an enhanced version. So what is a minimal working version? So 2 years ago, I had, again, we were working in pairs. So I had 2 students working in a pair, and they're big Harry Potter fans. I don't know if you're familiar with the books or the movies, but in them, the pictures on the wall move there, and they thought that was very cool. So what they wanted to do is put a screen, make a picture that moved with their Raspberry Pi there. And so their minimum project was just a Raspberry Pi with a screen connected to their screen, and then being able to just play a video of that person moving that sort of stuff. And they really wanted to take the old pictures of the sisters of Saint Scholastica and animate them. So they got pictures. So that their minimum was just, I think they did Summers, I forget, yeah, one of the original sisters, and took a picture of it. They found AI that would make the person smile and look around and say something or whatever. And then they did that as the minimum viable project there. And then by the end, they created a wood frame. We had a screen. We had to plug in the screen, of course, but the Pi was hidden behind the wood frame, and the wood frame held the screen. So the whole thing looked like a picture you hung up on the wall, and we had it all. Well, no, yeah, because they wanted to battery operate the whole thing. And we could battery run the Pi, but we couldn't battery run the screen. So it had to have a plug in it there. So eventually, but that was their project. So nice creative project. So again, I can list off things, but again, feel free to come up with your own option. We have little sensors. I have little servos Another creative project was a rabbit feeder that fed rabbits automatically, just dumped rabbit food. Because rabbits eat pellets apparently, and you just have to feed them periodically. Had someone who had a garden, and they had some animals. Well, this is back home, and back home they had animals getting into their garden. They wanted to set up a device so that it would play a loud noise whenever an animal entered the garden, and they had a big long thing. So we actually got a high-powered laser and a laser and just a light connector, so we could shoot this high-powered laser across the room and detect it at the other end. And so if anything broke that laser, that light beam, it would play a really loud noise. So did not work all that well. Controlling a high-powered laser and that sort of stuff is not. I just remember because we had to do it all on that side of the room. Well, and we had to shoot the laser that ball because we didn't want it to hit anyone else there. But it was an interesting project. It just in the end didn't work out as well as the student hoped it would. So again, so those are just ideas to get your brain thinking. So start thinking of it. Eventually, you're going to want to come up with. So let's see if I go back here to this unit. Phase one, again, you want to come up with a couple ideas and then complete this project review matrix, submit that, and describe what project you're submitted. And that has to be due by April 6th there. So by Sunday this week, we're going to do it. So we'll bring in more ideas on Thursday to talk about, and I'll bring in some hardware and some more ideas. And then start playing. So see if you can think. And we want an initial plan there. I don't prevent you from changing their ideas. So we want your initial idea of what you want to do by April 6th. But I don't lock you in. So you are allowed to change after that. Okay. So think of that. So I think I'm going to wrap up. If you want to spend some time looking on the final project, feel free to do that this week. We're going to do the lab. There are, because again, we're going to be doing these final project stuff, we're going to do less of some of the other stuff. So again, we've been doing explore activities in this class, so there's no explore activity this week. I assume you'll be working on it, and the final project stuff will take the place of that. Okay. So why don't we wrap up here and stop sharing here.